Hey everyone, this is Harith speaking. Can I get some sort of indication that everyone can hear me and see my screen well? Okay, cool. Thanks, John. All right, so let me share my screen. This is Blockchain 101 into a rabbit hole of money, decentralization, and smart contracts. Having spoken to Jean before, we will split it up into three sessions. For the talk itself, there'll be two parts. This is part one, and next month there'll be a part two. And a part three, where it's more of a hands-on workshop, will be following up at the end, where we basically try to set up blockchain wallets and use those to transact. But back to this part one first. So why I say rabbit hole? If you ever seen Alice Hey everyone, um, trying to see if I'm fully reconnected. All right, thanks, John. Um, Graham, I get disconnected again. I will quickly check. I'll upset of chain. So an analogy I like when you look at type of transportation, cars such as the Toyota or Mercedes and so on. Um, Bitcoin is one type of a blockchain, the way Toyota is one type of a car. Um, Hold on. Can you hear me well now? Okay, let me see. Okay, let me try again. And if I still get disconnected, I'm gonna pause a little bit and use a different connection. Yep. So a Toyota is one type of a car, and a car is one type of transportation. So Bitcoin is a type of blockchain, the way Toyota is a type or a brand of a car. And the difference between Bitcoin blockchain and cryptocurrency is that the first thing that you should know is that it's actually more crypto asset. Cryptocurrency is one subset of crypto assets. There are different types of crypto assets out there. Some examples are crypto tokens. So you can imagine this as if you were to walk into a casino, you would buy some chips and use those chips to transact within the casino. Or if you go to a school sports day and there are stalls, you can get a coupon and you use that coupon to buy products, food, or play games at the sports day. Crypto security is a representation of a real security, such as an equity of a company or a bond, and the crypto security is just a representation of that on the blockchain that is secured cryptographically. And lastly is cryptocurrency, and Bitcoin is one example of a cryptocurrency, but there are many different cryptocurrencies out there, and there are crypto assets that are not even currencies. And finally, there are the difference between Bitcoin with a capital B and Bitcoin with a small b. So Bitcoin with a capital B is the platform or the protocol itself, and the small b Bitcoin is the currency that you use to transact on the Bitcoin blockchain. So you can imagine it as the technology of a car, but to power the car, to get you from one place to another, you need to spend some gas or some fuel. And in this case, Bitcoin with a small b is the currency or the gas that you use to be able to move yourself from one place to another. And it's very important to understand these differences, because sometimes you will see Bitcoin with a capital B used to mean the currency, and Bitcoin with a small b meant to use the platform or protocol. So if you understand these differences, then even if there's a typo in the article that you're reading, from the context, you can tell whether they are referring to the technology or the platform, or they are referring to the currency itself. Other than these misconceptions, some concepts that you need to know is what money is. And if you've been to any economics class, or you can go watch some YouTube videos online, you commonly understand money as this store of value or unit of account or medium of exchange. And I'm not going to take too much time to explain this, because you can read this on just Google. But some things that aren't really focused on in economics classes are things such as that it has to have a limited supply. It has to have this feature called scarcity, where you can't simply print money out of thin air without any controls, because if you do that, then it defeats the purpose of money, right? Like if you and me can start printing new dollars or new euros, then very quickly the value of items will simply disappear. And we can see this in certain economies such as Venezuela and Zimbabwe, where the economy has had hyperinflation because essentially money has been printed too much into the ecosystem, and the value of everything just disappears. And I mentioned value, and it's very important to understand that money is itself just a representation of value. It's not a physical item. It's not the piece of paper or the gold bar that you hold in your hand, but it is this abstract concept, this thing that is in our head. Between different members of societies, we understand what money is, and we give value to it. And Uh, Hello. Testing. And check whether the audience can hear me. Okay. So I'm not sure if this connection is better. I'm gonna try it. I'm gonna not show my camera and then just share my screen. Hopefully that improves the connection a little bit. Okay. Money is a representation of value, and it resides where men believe it resides. It's a belief that's shared by different members of society, and there is no physical item that is money. What we know of these items are just representations of value. And you might say that there are these US dollar notes or your own local currency or gold bars, and these are physical items, right? So how come they're not money? But if you've used any of these modern e-wallets, you know that those are not even physical at all. It's just numbers on a screen. It's just pixels on your screen. And if you look at different cultures, different societies from different geographical locations or historical different times, you know that if you were ever in prison, a lot of people in prison use cigarettes as a form of currency. And if you were kids on a playground, you use Pokemon cards, or in different cultures, they use seashells as their currency. So if you ask any of us now, none of us would say that these are by themselves currency or money, but in those specific societies, in those specific locations, these are what's used as money. And it brings up that money is just what the society agrees to use, and it's not inherently part of any physical item that makes it money or not. Some examples are, if you look at Venezuela, where they've had hyperinflation in the millions of percents for the last number of years, you can see that the physical paper that they previously used as money now has no value as money, and people much prefer to use it as origami handbags or to draw cartoons on. And by this way, they actually have more value from these pieces of paper than using it as money. Where I come from, in Malaysia, there are these things called the duit pisang, or in English, banana money. And historically, when the Japanese military was occupying Malaya post-World War or during World War II, they enforced this use of the Japanese currency. And it's called banana money because the $10 note has a picture of bananas. And imagine you were there at that time, and you were a farmer, maybe of bananas yourselves, and every day you sell your bananas in the market, and you keep some of the money that you've gotten from your sales, and you store it maybe underneath your bed to for a better future. And maybe you saved up $1,000 worth of this banana money, but then one day you wake up and you realize that the Japanese military has left Malaya. They've been defeated by the British Army, and they've gone back home. And while it's a happy day for the people in Malaya, for you it's a little bit bittersweet, because while it's happy to have your independence, your $1,000 that you've been saving for your future, for your kids, now no one will want to accept that money from you anymore, because no one will believe that the Japanese army will be around to enforce the use of that money. So just like that, your $1,000 has disappeared into thin air in the blink of an eye. And more modern data, if you look at even the US dollar over the last couple of centuries, you see that the value of a dollar has gone down, such that a dollar that was worth $1 in the 1850s is now worth less than 90% of what it was. And we can see even in the last few years that the value of dollars have gone down and down. And if you look on the right side, this is an official chart from the US government from a website called WTFhappened in1971.com. You'll see that a lot of these metrics, in this case, consumer price index that tracks inflation, but even other metrics such as median salaries, household income, you can see that a lot of these metrics have gone crazy or haywire since 1971, where a big reason that is being put forward is that was when the US government went off the gold standard entirely, and other governments around the world followed it as well. And it sounds a bit of like a conspiracy theory to say these kinds of like dramatic words, but if you look at just wherever you're staying, just look at the price of a house. Where I stay, the price of a house where my parents are living, and the house that they bought about 15 years ago, has gone up maybe 3 times in that time. And the salaries have not kept close anywhere near that rate of increase. So that even if you're working the same job as your parents, at same rank, same seniority, you earn a lot less every month. And that is some sort of inflation that isn't even tracked in this consumer price index. And you see a lot of people in my generation who cannot afford to buy a house or buy cars anymore unless they get into this crippling debt. And why all these matter is that Bitcoin was created as a reaction to all of this. When Satoshi created Bitcoin, the first ever block in there was he quoted a headline from the Times newspaper in the UK: Chancellor on brink of second bailout for banks. And Bitcoin is a peaceful revolution against this irresponsible printing of money by central banks around the world. It is a form of money that is independent, that is not controlled by any government, any company, or any closed group of entities. So other than money, the next thing we want to know is decentralization. And that sounds like a lot of jargon, but it's actually a very simple concept. If you are or know anyone who is a Muslim, you know that the Quran wasn't this book that fell from the sky. It was a series of thousands of verses that was memorized in the exact content and exact order, such that if I was to come to a society of Muslims and I wanted to tell them to just add one little verse that says Harith is handsome, if there were only two people that memorized the Quran entirely, then I can find them and I can just bribe them, maybe pay them $10,000 each for them to just add this one little verse that other people may not realize is even there. But if there are hundreds or thousands or even millions of people who memorize the Quran entirely, then it becomes progressively more difficult and essentially practically impossible in the current time for someone like me to be able to have the money and the coordination abilities to bribe all of these people together and show a different version of the Quran than it is. So the Quran is decentralized because there are thousands, if not millions, of people around the world who memorize it in its entire content and order. And so it's difficult, nigh on impossible, to change any content of this Quran. Another example is that of a wedding. And other than this sort of happy ever after kind of event, celebration, weddings also play a very practical purpose in societies, because if there are 100 people or 200 people that attended your wedding, then if the next month you wanted to go to the neighboring village with a different woman or man than the one that you're married to, then if there are 200 people who essentially were witnesses to your wedding, then it's higher chances that someone will catch you in the act of going out with someone that's not your spouse. And that way society has a mechanism to make sure that people are not behaving in a way that is bad for the society, and basically have a way to make sure that people are behaving in their best behavior. Compared to if there was only one priest or imam or rabbi that was officiating the wedding and there were no witnesses, then the chances of you getting away with this misdemeanor is much higher, because there are not as many witnesses who can monitor and fact check if you are going out and doing something that is wrong. A more modern example is that of Google Sheets. So if you've ever used Microsoft Word versus Google Docs, or Excel versus Sheets, you know the difficulty of doing group work using Microsoft versus using Google. Whether it's in your college or for actual work, if you are using Word, then every time you want to make a change, you have to do all of it and save it, and then send the file over to your teammate or sync it in a folder somehow, and then they can start working on it. Whereas if you were to use Google Docs, or even Microsoft, to be fair, now has Microsoft Teams, you can do all of this work online in sync with each other, so that you don't have to worry about making sure you're on the correct version, or worry that one of your teammates is accidentally or intentionally deleting your content without you realizing. And this is decentralized because Google has thousands of servers around the world. So that if you have an internet connection, you can connect to any of these thousands of servers. And even if some earthquake attacks, let's say the west coast of the US, and a bunch of servers go down, they can rely on other servers in other parts of the world to keep your document up and running and be able to update whenever you make any changes to your document. You might say that Google is not fully decentralized because it's one company and you still have to trust the company, which is fair, and why it's not the same level of decentralization as blockchains. So in essence, if you understand money and decentralization, you actually understand Bitcoin already, because Bitcoin is just decentralized money. What does this mean actually? So imagine you were a doctor in Syria before the wars happened, before all the devastation happened to the cities in Syria. You were living a happy life, maybe not super wealthy, but a comfortable life for your family. You have a house, you have a car, and a job that you enjoy. But let's say the bomb started to drop and you felt that it wasn't safe to stay in Syria anymore, and you had to move somewhere else. And with any other form of money, it would be a pain. So if you are using your own form of currency, your banks would already be in a troubled situation and wouldn't be able to process your payments, especially internationally. If you were to use like physical paper, that's still the same. You're still using your national currency. And even if you have US dollar notes, which is still better, but you still have to carry these physical items around. And there's only so much you can carry along with you when you are traveling across borders. And you face the risk of being robbed or forcibly having this money forcibly taken from you. So compare that with Bitcoin, where all you have to do is just memorize your private key or have it written down somewhere safe, and you can carry it with you. And even when you're halfway around the world, you can access your wallet back again and get 100,000 or whatever amount that you had in your wallet. And even though it's a difficult life that you have to start over, but now you can start from with that bit more money that you have with you instead of starting completely from scratch. Okay, so that's what Bitcoin essentially is, decentralized money. And to elaborate a little bit more about that, so our modern system of finance typically relies on a central third party, whether it's a bank or a money changer or some other similar institution. Unless you are paying in cash, you always have to trust someone else to broker a transaction between you and whoever you're transacting with. An example is, let's say I'm in Malaysia and you are in the US. If I wanted to send money to you without any third party, then I can sort of mail that money to you, and you can tell me that you've never received it. And there is no way for me to know that whether you are saying the truth or not. I can keep trying and you can keep telling me that you've never received it, even though you actually did receive it. And vice versa, I can tell you that I have paid you, and it just got lost in the mail somehow. But in fact, I never actually sent any money to you. So we have these banks, these trusted third parties, because I don't have to trust you and you don't have to trust me. But as long as we both trust a bank, then we know that the transaction can work. But there are certain problems with this. So, for example, if you look at Venezuela, Syria, Zimbabwe, these are places where the institutions have failed, and you cannot trust these financial institutions anymore to broker a transaction for you. And even if not in these dramatic cases, if you make payments, especially internationally, then you would have to use someone like PayPal, who would charge you maybe 3 to 5%, and they don't actually provide any value to you or the person who's receiving the money, other than being a trusted party that can execute the transaction for you. And that's money that you otherwise would have saved or the other party would have received more of. Now compare this with a situation where there are a bunch of us here and we just trust each other. We build a group to build a sort of money between us. And it could be a WhatsApp or Telegram group where every time someone wants to make a transaction, let's say I want to pay John, then everybody opens up a book or an Excel spreadsheet and they update everyone's balances and they will check that, okay, if Harith has at least 10, then he can send 10 to John. But if he doesn't have, then we will block this transaction and you will fail. And if everybody keeps updating their ledger or whether on a book or a spreadsheet, then this thing can work. But you will very quickly realize that, even if there's only 5 people, it's already getting tedious to keep doing. And if there are more, if there are hundreds or thousands or millions, then it becomes impossible for us to be able to do this and continue living our lives, because 24/7 all we'll be doing is just checking transactions to make sure they go through. But what if instead of human beings, we use computers to check these transactions? And it may sound still a bit crazy, but if you can imagine how our computers and even our phones can play streaming videos, can play massively multiplayer online games, that's a lot of computing power that are used compared to just simply updating and verifying transactions or ledgers. Those are much, much simpler to do. So it's actually very, very possible for computers to do these things, even though for human beings, it's a difficult task to do. And importantly, when it comes to these blockchains, these groups of computers have open source code, which is what everybody's joining this event for. And we know that open source code is fully public, that there's no hidden walls that hide any part of the code. Anyone who wants to can verify that the code is doing what is set to do, as long as you understand the underlying coding language that runs this piece of code. And in this way, the code is trust minimized, because you don't have to trust any one person or group of entities to secure the code. Anyone who wants to can check the code and can run this computer to validate transactions. Okay, so that's some introduction to basic concepts of the blockchain. I'll then go over some features of blockchain 1.0, which is common for Bitcoin and the blockchains of that era and the ones that came afterwards. So the first thing is to cover what is a block explorer. So I mentioned I work for Etherscan, which is a block explorer for Ethereum. And when it comes to block explorer, the first thing that you need to know is that blockchains are not anonymous. So if you've ever heard about criminals using blockchain to transfer their drug money or prostitution or other sort of crimes, if you were one of these people and you wanted to use the blockchain to transact, you should know that it's absolutely the worst form of money you can use, because in many ways it's even less private than simply using cash or normal financial systems. And why do I say that? So if you open a block explorer, you can enter the blockchain address for any address in the world. So you can see the top left here. As long as you know someone's address, you can enter the address and you can see everything to do with the address. You can see their balance, you can see their transaction history, who sent money to them and who received money from them, and at what date and what amount. All of these are fully transparent, fully public to you, for you to know, and you can trace these transactions. You can see this address, and it sent money to which address, and it received from which address, and you can do a lot of these sort of analytics to trace where transactions went to. And this is what governments and regulators around the world have been doing for the last few years. So if you're a criminal, you don't want to use blockchains because it's fully transparent and fully can be traced to you. And even if it's a crime that you did 20 years ago, 20 years later, someone can still check the blockchain and still trace these transactions back to you. The only saving grace you have is that the blockchain address isn't tied to any identity. So there's no Harith that is tied to my address. There's no passport number that is tied to the address. So I cannot simply guess what your address is and enter it to the Explorer and see everything about you. But the thing is, as long as I've made any kind of transaction with you, then I know that the address that I transacted with has some sort of relationship with you. And if I know a bunch of other addresses and I can link them up together, put the pieces together like a jigsaw puzzle, then I can make a lot of very sort of strong, educated guesses about who owns a particular address or is tied to that address somehow. And one way you can think of this is imagine a library where you can walk up to the librarian and you can tell him, I want to see the contents of this book on shelf 36A. And the library will never block you from seeing a particular book. There is no restricted part of the library. Anyone can walk up to the librarian and they will show you the content. And no one can stop you from seeing any content in the library. It's important to understand that different blockchains are their own libraries. So you cannot walk up to the Bitcoin library and ask to read a book that's in the Ethereum library and vice versa. And closely related to block explorers are wallets. And the term wallet is a little bit unfortunately named. It's actually a lot closer to a safety deposit box, where these safety deposit boxes are in the cloud, on the internet. So there's no physical vault that's storing these items. These are all on the blockchain, which is all on the internet. And it's more like the safety deposit box than a wallet, because when you think of a wallet, you think of something that you carry around with you. And if you use these things called a hardware wallet, then you are carrying these devices. But the devices by themselves are not the wallets. They are more just the keys to open the safety deposit box that exists online. And then you can take your wealth from inside. But they by themselves are not the wallets. So think of it as this special shelf that you have in a safety deposit box. And what you generally call wallets are just the key to open that box. And you're not actually carrying, $1 million of Bitcoin everywhere you go. In many cases. And if you go back to the library analogy, the wallet, what it allows you to do is that you can go to the librarian and instead of saying, I want to read the contents of the book on 36A, I can now tell the librarian that, hey, I want to move my book from 36A to this shelf 17B. And if I want to do that, then the librarian will ask me, okay, can you prove that you own the shelf 36A? And if I can prove it, then they will move it for me. But if I cannot, then they will not do so. And even if I did prove it and I moved a book from 36A to 17B, and like literally 1 minute after that, I tell him that, hey, sorry, I actually meant to move it somewhere else. Can you return it back to 36A? Then it doesn't matter. As long as I do not own the keys to 17B and I can't prove that I own it, the librarian will never listen to me. So what the wallet does is it allows you to move the contents around instead of just reading the contents. And wallets use this technology called public-private key cryptography. I'm sure there are other people who can go a lot more into detail about this, but for the purposes of this talk, what you want to know is that just a simple layman understanding that a public key is like the mailbox to your house. It's like the address that you want to tell eBay or Lazada to transfer, to send a parcel to you, so that if you want to buy a refrigerator, then they know where to send that to your house. So that's the address. And the private key is like both the mailbox and the key to open your house door. And it's very important to understand that it's not just the key. It's also the address to your house. So if you've ever given someone your private key, it's literally the same as if you're giving them a map with an X marks the spot and the key to open your door. And if they then go to your house, even if they don't know you, they can go to your house, open the door, take everything that's inside and move it to their own house. And if they do that, there's nothing that you can do to stop them. And that's where the second key thing I want to highlight is that when it comes to blockchains, you are your own security. There is no Google forget password. There's no insurance, deposit insurance. There's no central bank that can help you. If you lose your keys, it's at the mercy of whoever has those keys. And you even hear stories of people, who were married and then got divorced, and then their ex-spouse goes and takes everything that was in their wallet, or if it was a brother or a friend, it might be someone that you trust now, but 5 years later, your relationship's broken down and they can take all the wealth that's in your wallet. So a lot of people actually become more paranoid when they've been in the space for longer. There are different types of wallets. So the most basic ones are called paper wallets, where literally you set up a wallet and they will show you this sort of image or PDF that has your address or public key and your private key, and you never want to show this to anyone. So this one that I'm showing you is just an example. Even if you open this, you'll see that there's nothing inside. But if it was my real wallet, I should never, ever, ever show this to anyone. And why it's called a paper wallet is because you shouldn't even save it in a digital format, because if any of you know a celebrity who's ever had like an adult video shared, you know that a lot of cases, it's not because they purposely want to share this to the world, but they did it for themselves and their partner, and they saved it in their computer, and maybe they deleted it and they sent it for a repair at a computer workshop. And these computer workshop repair people know that there is no such thing as a file that gets digitally deleted. Unless you burn the hard drive, they can always recover a file once you've deleted it. So same thing applies to your wallet. If you delete your file, but then later on your computer gets stolen, or you've sold it off, someone can still recover the file and still get that private key and take everything from inside that wallet. So what you want to do is you want to print it on a piece of paper, laminate it, and place it somewhere very secure in your house or in some vault somewhere. You can even split them up into different locations, kind of like a Horcrux, if you're familiar with Harry Potter and Lord Voldemort. That you can even use steel wallets, where you engrave it on pieces of steel, so that you don't get it, you don't risk having your private keys sort of wet or burnt and so on. And I mentioned a little bit earlier, hardware wallets. These are devices that you can carry around with you, and you never see the private key, and it's fully encrypted. If anyone steals this device, they also can't see your private key, and you can set a pin where it will take them a very long time to try and break into this device. And if your device ever gets stolen, you can go back home and use your paper wallet, which you've stored at home and never carry around with you, and you can unlock your wallet, move everything from there into a completely new wallet that's safe, so that even if this thief eventually gets to hijack past the encryption of your hardware wallet, by the time they do that, they will see that it's fully empty. And lastly, there are what's called Web3 or smart wallets, and these are specifically for blockchain 2.0 and above, where you can use either extensions to your browser or desktop or mobile apps, and you can interact directly with a website without having to use any account or password, or transferring between different kinds of money or currencies. You can literally use, for example, Ether, which is a currency for Ethereum, to do transactions automatically with these different decentralized platforms, which we will cover in the next session. Okay, next we have mining. So before we can talk about mining, we have to first talk about hash functions, which if you've done any programming, you should have, or computer science, you should have understand this by now. But a very short explanation is that hashing allows you to do things such as if you enter the word cat and the word car, which only has one difference in letters, you can see that the result for cat is completely different from the result for car. And even though they have the exact same length, you cannot tell from the result of either one what the input was. And even if I tell you that the first one is based on cat, you cannot sort of reverse engineer from the result to guess that the input was actually car. It could have been any word of any length, and potentially could have given the same result as the result that you see for car here. The analogy I like to use is that of a snowflake. So snowflakes are all unique in the world. There's no snowflake that's similar to another. And if you then melt these snowflakes into puddles of water, then they look exactly the same. And to sort of reverse engineer that to the original snowflake is extremely difficult. In snowflakes, it's probably a lot more difficult, maybe even impossible. With hashes, it can be a little easier, but still very, very difficult. If you were to see a puddle of water and to like convert this into the snowflake that it was, the difficulty is extremely high. Another analogy is if you think of your high school maths, if you talk about exponentials, if you take 7 to the power of 3, is a lot easier than to find the cube root of 7. So one mathematical function is a lot easier to compute versus the reverse of that same function. So a hash function is just that. It's easy one way and a lot more difficult the other way. Why does any of this matter? So before that, Merkel trees are what blockchains use, and these are hashes of hashes. So you can think of one block having many different transactions, and they are one color, let's say one output. And if you change just one block in the root or the base layer, then you can see that apparently the color is completely different than what it was. So even if you were to change just one block, the whole or one transaction within a block, the whole block becomes completely different, and it can easily be shown that it is different. So people can easily validate that something has been corrupted. These computers that are computing and validating transactions. But a question that some of you might have asked is, why should I run my computer to validate a transaction? If the only two people that are transacting are Harith and John, and I'm sitting here, I'm running my computer, I'm paying my electricity bills every month, I don't have any incentive to do it if I'm not making a transaction. And only these two people are transacting. So what I might then decide is, okay, I'm not that nice of a person that I want to waste my electricity every month. So I'm going to shut down my computer and only turn it back on when I want to make a transaction. And if everybody does this, then the whole system collapses, because if only Harith and John are the two people that are running the computers that's verifying these transactions, then the two of us could potentially hijack the blockchain. We can change the ledger and manipulate it in any way that we want, because no one else out there is monitoring what we're doing. You know, there are not any wedding attendees who can check that I am behaving wrongly. So what Satoshi Nakamoto, the creator of Bitcoin, did was he created this incentive element where randomly for every single block that gets created, one out of these computers that are validating will get a reward of new Bitcoin. And by doing so, even if you're not making any transactions, by running your computer, you stand a chance to earn a little bit of Bitcoin so that you can earn a revenue that covers the electricity bill that you've been paying. And this is actually for me, the most beautiful thing about Bitcoin is this incentive element, this game theory that has been created where you want to run your computer to validate your transaction because you get rewarded for doing so. It's not a programming thing, it's a incentives thing that make people want to validate a transaction. And the more people there are, the more decentralized the blockchain becomes, the more secure it is from being hijacked or bribed by a specific group of entities. So when you mine a new block, you get both the block reward and a transaction fee. So a short note: transaction fees are you have to pay every time you want to make a transaction on a blockchain. This might be a little bit weird for us who are familiar with the normal sort of conventional traditional finance, where when you want to pay to someone, we don't actually have to pay a transaction fee on top. But in effect, actually, when it comes to using, for example, credit cards, the merchants are actually paying the transaction fees. So even though you as a user are not paying, the merchants are paying the transaction fees to Visa and MasterCard. And they actually sort of include the costs of this in the prices that they sell to you. So it's abstracted away, but in fact, you are paying transaction fees for using the system. And another beautiful thing about blockchains and Bitcoin is that there is this thing called adjusted difficulty, where if there are many people that are mining Bitcoin, so let's say there are 100,000 computers or nodes that are mining Bitcoin, then the difficulty will spike up, so that if there are 100,000 people and they're all trying to guess the answer to that hash function to reverse the calculation, and the more people there are, you would expect on average the time it takes to be much shorter because more people are trying. But the Bitcoin blockchain has been created such that the more people there are, the difficulty will spike. So that on average, you expect a block to be once every 10 minutes. And for Ethereum, for example, once every 15 seconds. And yeah, so to recap, mining is just this action of trying to reverse engineer a hash function. You essentially are just guessing the answer for a puzzle, and the first the first node that manages to do it gets this mining block reward. This is one example of a consensus mechanism called proof of work, and there are different types of consensus mechanisms out there. Bitcoin uses proof of work, but others may use different ones. One quick thing to mention also is that there are a difference between miners and simple nodes. So a miner is a node that is also trying to solve that hash function puzzle, whereas a node is just monitoring, just validating that a transaction is a block that is being proposed by a miner is a correct block, and there's no hanky-panky going on behind. So to run a node, you are essentially doing it altruistically. You are doing it for the benefit of the blockchain as a whole, whereas to run a miner, you are also incentivized to do so. When it comes to mining and the word blockchain, it actually, if you look at this graph, it actually tells you how the word blockchain came about. So transactions are grouped into blocks, and blocks are added on top a chain of other blocks. So such that if you wanted to change the content of a particular block that was 100 layers or 100 blocks ago, it gets much more difficult than trying to change the content of one recent block. Because every time you want to change the content here, it will affect every other block that came afterwards. And this is where the term blockchain comes from, because it's a chain of blocks. And with exponentially higher difficulty, the more blocks you are trying to hijack. Okay, I'm a bit short on time. I might go a little bit over time, but I'm going to try and do this very quickly. So the final point that I want to cover here is on essentially exchanges. So that's the answer to this question here. How do I buy cryptocurrencies? You can do it over the counter or on exchanges. Over the counter just means you find someone who has some Bitcoin and you offer to buy off them. But in the real world, it's much more likely that you will go to some sort of marketplace when you want to transact something, right? Because let's say you go to a market, let's say you have a loaf of bread, it's much more likely that you can go to a market, sell your loaf of bread, and buy, let's say, a piece of chicken. There are a lot more people there who are also selling their own wares. So the chances of you finding something that you want at the price that you are willing to accept is much higher when you go to a market. So an exchange is exactly that. It's just a marketplace. There are different types of exchanges. So one way to divide them is the fiat to crypto and the crypto to crypto ones. So fiat crypto are, fiat means your national currencies, your US dollars and euros and so on. And these exchanges typically are regulated because it's using the national currency, and central banks and so on will regulate these institutions. And this is where you want to go to buy, let's say, Bitcoin or Ethereum or some of the top currencies out there using your dollars. But there are thousands of cryptocurrencies, and these fiat crypto exchanges may not support them. So in these cases, you might want to go to a crypto to crypto exchange to trade in your Bitcoin or Ether for one of these obscure coin that most people have never heard about. For fiat to crypto exchanges, there are also different kinds. There's broker and marketplace. So a broker is where you go to them and you accept whatever price that they're offering you, whereas a marketplace is more like a stock broker account, if you're familiar with that, where you can put in limit orders, and there are makers and takers and so on. And the exchange is just hosting a marketplace for many different people to trade with each other, whereas a broker is where the exchange actively becomes the counterparty that you are transacting with. It's extremely important to understand that exchanges are not wallets. So if you've ever heard of these stories about how Bitcoin has been hacked, they've lost hundreds of millions of dollars. In actual fact, Bitcoin has never been hacked. A lot of times when these news come out, what has actually happened is that the exchange has been hacked, not the Bitcoin protocol itself. And so exchanges are very, very different from wallets. And that's extremely important for you to understand. To give an example, so exchanges are like a money changer. And the only difference with this kind of money changer is that let's say you walk up to this money changer and you say you want to exchange your dollar for maybe 2 euros. So let's say you give $100 and you are getting back 200 euros. And the difference here is that when you go and do this exchange, you tell the money changer that, hey, I don't want to take this 200 euros back with me, put it into my own wallet. What I'll do is I'll trust you to keep this secure. So maybe next week when I want to exchange it for some other currency, I will come back to you then. And in this case, you might go back home and go to sleep. But then the next day, you might find out that the money changer has been robbed or burnt down, or the owners have run away with your money. And when this happens, there's nothing you can do because you trusted them with your money. And exchanges are similar. You are trusting them to hold on to your cryptocurrency for you. And if they then run away or get hacked, there's nothing that you can do because you've trusted them with that money. And so exchanges are actually antithetical to what blockchains are meant to be, because when it comes to blockchains, you're supposed to not to have to trust anyone. You as long as you have a wallet and you secure it yourself, you never have to trust any other party out there. But exchanges are where you trust them to hold on to your money for you. So a lot of times when these hacks are happening, it's because the exchange has been hacked and the Bitcoin protocol has never actually been hacked. It's as if a money changer gets robbed and people are saying that, hey, the US financial system has been hacked, when in fact it's only that one money changer that has been robbed and not the entire system itself. Okay, so that's pretty much what I have for this part one. Yeah, so we will continue this in part two. And if there's any questions, I'm not sure if there's any time to answer, but if not, we can address that in the next session. So yeah, thanks everyone for listening, and I will catch you again next month.